Okay, this is 10.3b, the second video on lesson 10.3. We're going to look at addition and subtraction of monomials. We just did some multiplication in 10.3a and found that it wasn't too bad to do that. But one of the things that's important to realize when you're adding and subtracting monomials is that you can only add and subtract monomials or terms that are considered similar. They have to be similar. Okay, so what does it mean to be similar? They have to have the same variables. So like this one I have up here, it has an x and an x. So that's good. And they have to have the same exponents. I'm sorry, I forgot the E on exponent. So, in this one I have shown up there, I've got a 2 and a 2. That means these can be added, or they can be combined, because they have the same variables and the same exponents. So I just add the negative 3 to the 15, and I get 12. And then I don't do anything with these. I just tag them on to the answer. So whenever you're adding and subtracting, the variables never change. Just the number in front of the variables are combined. So if you look at the second part of, let me get rid of all this, the second part of example 6, it has 9x squared y minus 20x squared y. Because the variables are the same, an x and a y, an x and a y, and the exponents on the variables, a 2 on the x, a 2 on the x, a 1 on the y, a 1 on the y, we can combine those. And we know our variables and our answer are not going to change. So all we care about is the 9 minus 20, so negative 11, and that's it. But when we have something like 5x squared plus 8y squared, notice our exponents are the same, but our letters, our variables are different. That means this is done. We cannot do anything to that, so we call it good. So example 7, what we're doing here is we're going to be doing a couple different operations rather than just one. So when we have something like example 7, letter A, we're going to use distributive property first of all. I mean, there's several ways to solve this, but we're going to do the distributive property in this one. So we're going to multiply the x squared times 1, and then the x squared times 6 over x. So because the x squared is actually over 1, because anytime you make a whole number or something without a fraction, you put a line under it and put it over 1. So we're going to multiply the x squared times 6, and we put the number first. It doesn't matter, it's still the same, but we put it first just because it looks better, and then the x on the bottom. So now we have x squared minus 6x squared over x. But what we're going to do is we're going to look at this right here first. And notice we have an x on the top and an x on the bottom. So this is actually 6x to the 2 minus 1. So that x squared there at the beginning, this stays the same. But let's change this to 6x to the 2 minus 1, which is 6x to the first power, which we don't even have to show that one. Now this looks a lot prettier than this up there. So we're going to go ahead and see if we can combine anything. And we have an x there and an x there, but this has an exponent of 2, this has an exponent of 1, so therefore that's as much as we can do with that particular problem. And that brings us to the second part of example 7. We have AB, and we're multiplying it by 1 over B minus 1 over A. Now that looks kind of confusing there, but if we just do these one step at a time, we're going to distribute. AB times 1 is AB, and it's over B, minus AB over 1, which is AB over A. Now we can go through the whole mathematical procedure, Or we can look and see that we have a b there and a b there, so we can cancel them because b over b is 1. We have an a there and an a there, so we can cancel them. We cannot cancel across the minus sign. We cannot cross this b with this b because they're separated by a minus sign. Whenever your fractions are separated by a plus or minus sign, you can't go across. It's only if this was a multiplication sign that you could cross this out with this out. So what do we have left? On the left hand side we have an a, and on the right hand side we have a b, and that's our answer. So this is example 8, and if you remember from a while back, I said that when we have this division line here, we try to simplify what's on top, simplify out what's on bottom before we start going across the line and doing anything. So what we're going to do is we're going to multiply these first. And if you remember from a little while ago when we multiplied, we just multiplied the numbers. And then we take the x to the 4th and x to the 7 and add the 4 plus 7 and get 11. And then we multiply the y's by taking the y to the 1st power and y to the 5th and add those and get y to the 6th. Then we have x to the 5th y squared. Now we've got a simple fraction here with no multiplication, no addition, no subtraction, and we can start going across the line there and getting some simplification here. So 18 over 9 is 2. In fact, it's 2 over 1. So let's write it as 2 over 1 because we have some numbers that might be on top the division sign and ones that might be underneath. So let's just make a long line there. X to the 11th over x to the 5th is 11 minus 5, and that gives me 11, or I'm sorry, it gives me x to the 11 minus 5 is 6. Y to the 6th over y squared is 6 minus 2, which is 4. Nothing is going on the bottom, so let's just go ahead and get rid of the division sign now, and that, since there's nothing on the bottom, and leave that as our answer. Now when you look at example 9, we're going to combine some things that we did with dealing with scientific notation. So we have 6.8 times 10 to the 5th, and we're going to multiply that by 3.9 times 10 to the minus 7. If I can get this, there we go. And 7.8 times 10 to the minus 4. Alright, so what we're going to do again is we're going to do what we can on the numerator, what we can on the denominator before we cross the line. So we're going to take 6.8 times 3.9 and get our number there. So 6.8 times 3.9 gives me 26.52. And then we've got a 5 and a negative 7. So 5 plus negative 7 is going to give me a negative 2. Then I'm going to divide that by 7.8 times 10 to the negative 4. So let's go ahead and divide our numbers there. And that gives me 3.4. Now let's go ahead and do our tens here. So we have a negative 2 up on top, and we're subtracting a negative 4. So this is negative 2 minus a negative 4, or plus. So then that's going to give me a 2 up there because negative 2 plus 4 is positive 2, and that's our answer. So for example 10, we have 14x to the 5th over 2x squared, and we're going to add 15x to the 8th over 3x to the 5th. Okay, so what are we going to do with this? We're going to look at this first of all and see if we can simplify it before we try to combine it with this here. Alright, so 14 over 2 reduces to 7. Yay. Alright, and then we look at x to the 5th over x squared, and that reduces to x to the 5 minus 2. Then we look at this here. 15 over 3 reduces to 5. And x to the 8th over x to the 5th is the same as the x to the 8 minus 5. So x cubed. So now we have these to combine. Well, before they can combine, we have to look and see that they're like terms, which means do we have the same letter and do we have the same exponent on the same letter? And we do. So we can take 7 plus 5 and get 12, and we tag on the x cubed, and we're happy campers because we're good to go there.